Children, good morning once again. Now welcome in second part of video of force. That is moment, turning effect of a force or torque. We know that torque is defined as the product of force and perpendicular distance between them. That is moment, turning effect of a force or torque. Another meaning of moment means a very short period of time or a particular point in time. The moment of a force is a measure of its tendency to cause a body to rotate about a specific point or axis. Another meaning of moment of force is product of force and perpendicular distance between them. Children, this is the pivot O point and P point A is another point. If apply force this lamina, then apply by force is F. To consider a body which is pivoted at point O, if a force is applied horizontally on a body with its line of action in the direction AP as shown in this figure, the force is unable to produce linear motion of the body in its direction because the body is not free to move, but this force turns or rotates the body about the vertical axis passing through the point in the direction shown by the arrow. Children, here O is the pivot point and P is center point and F represent two direction of force for the moving the body from this direction that is anti-clockwise direction. Children, very important factors. Moment of force has two factors. Number 1 point, the magnitude of force applied, and second, the perpendicular distance of the line of action of the force from the axis of rotation or pivoted point. Another meaning of moment of force, the turning effect, very important point, keywords. The turning effect on the body about an axis is due to the moment of force or torque applied on the body. Another meaning of torque, the moment of force or torque is equal to the product of the magnitude of the force and the perpendicular distance of the line of action of the force. Children, we know that formula of torque is equal to product of force and perpendicular distance between them, which is cross product. Therefore, torque is equal to FD sine theta, where tau, it means tau is the torque, F is the force, D is the distance, theta is angle between the force and perpendicular distance between them. Okay, children, we know that unit of force is Newton. A unit of torque is torque equal to force into perpendicular distance, FD. F means Newton meter. Unit of torque is Newton meter. Children, we know that the SI unit of force is Newton and that of distance is meter. So the SI unit of moment of force is Newton meter. Children, CGS, MKS, FPPS. It is the types of systems. Number 1 point, MKS system. Second point, CGS system. Third point, FPPS system. MKS system is defined as meter, kilogram and second. Second, CGS system is defined as centimeter, gram and second. And third point, FPPS, foot, pound and second. But we will discuss about MKS. Very important role for MKS. Because all units is defined in this book MKS form. Okay children, please learn to this point the unit of force. Children, force is equal to Newton and torque is Newton meter and distance is equal to meter. Children, we will change of this. Torque is equal to FD. FD means MA into D. M means kilogram acceleration meter per second square and D means meter. So children, torque equal to 1 kilogram, torque equal to kilogram meter per second square into meter. So kilogram 10 power 3 gram, meter 10 power 2, 1 meter equal to 10 power 2 centimeter into 10 power 2 centimeter upon second square. Therefore 2 to 4, 3, 7, 10 power 7 gram centimeter square per second square. Gram per centimeter second square is represented by dyne centimeter. Children, that is 10 power 7 dyne centimeter. Okay children, 1 kgf into m is equal to 9.8 Newton and 1 gf centimeter is equal to 980 dyne centimeter, because 1 meter equal to 100 centimeter, because 1 meter equal to 100 centimeter. Children, turning effect movement has two directions, clockwise and anti-clockwise direction. Conventionally, if the effect of the body is to turn is anti-clockwise, the moment of force is called the anti-clockwise moment and it taken as positive. While if the effect on the body is to turn clockwise direction, the moment of force is called the clockwise moment and its taken will be negative. Okay children, very important part. This is this example of disc, anti-clockwise direction and clockwise direction. Anti-clockwise direction and clockwise direction. It has positive value or it has clockwise, that is negative value. Children, second point, by changing the direction of force shows the anti-clockwise direction and clockwise direction. Okay children, so the anti-clockwise and clockwise moments produced on pivoted axle by changing the direction of force. F is the free of axle. Common example, very good example of the door. Very good example of the turning force is the door. It has hinge and handle of the door and frame fixed in the wall. Frame fixed in the wall. Children, if fixed from the wall. To open or shut a door, we apply a force, push or pull, F normal, to the door at its handle P, which is provided at the maximum distance from the hinge, as shown in this figure 1.5. We can notice that if we apply the force at a point Q near the hinge R, much greater force is required to open the door. If the force is applied at the range R, we will not be able to open the door howsoever large the force may be, because for the force at R, torque will be 0. Thus, the handle P is provided near the free end of the door, so the smaller force at a larger perpendicular distance from the hinge produce the maximum moment of force required to open or shut the door. Second point, the upper circular stone of hand floor grinder to provide with the handle near its the rim, so that it can be easily be rotated about the iron pivoted its center of applying a small force of the handle. Next, third examples, the turning of steering of wheel. Motion of handle of steering wheel, it is the anti-clockwise direction, it is the clockwise direction. For turning a steering wheel, a force is applied tangentially on the rim of the wheel, which is given in this figure. The sense of rotation of wheel is changed by changing the point of application of force without changing the direction of force. When the force F is applied at a point A of the wheel, the wheel rotates anti-clockwise direction, while in figure of this 1.6b, the wheel rotates clockwise when force F is applied in the same direction at point B of the wheel. This. Fourth point, bicycle. In a bicycle, very important point, in a bicycle, to turn the rear wheel anti-clockwise direction, a small force, it is axis point, moment of this direction. Okay children, to turn the rear wheel anti-clockwise, a small force is applied on the foot pedal of a toothed wheel of size bigger than the rear wheel, so that the perpendicular distance of the point application of force, perpendicular distance means F. Right children? F from the axle of wheel is large. The toothed wheel is joined to the rear wheel by chain through their tooth. Next, another example, fifth number, a spanner, that is wrench. It is the wrench and spanner. This direction is anti-clockwise direction. Force is this direction. Okay children? So a spanner used to tighten or loosen a nut has a long handle to produce a large moment of force by small force applied normally at the end of its handle as shown in this figure. Okay children, this is another example of jack. Jack is used to lift a heavy load such as vehicle has a long arm so that less effort is needed to rotate the jack. Okay children, have a nice day, good day.